Hospital reporters, pride and dignity. Stop the New World Order. Welcome to Pan Motif and welcome to this. It's kind of a follow-on actually to the videos I've recently done about Three-Eye Atlas and Professor Avi Loeb. What I'm going to do now is I'm going to talk about another subject which is kind of parallel to it. It's deconnected via the Galileo project, which is his particular endeavor. And it's about a new discovery, which I think is at least as significant as Professor Loeb's discoveries about Three-Eye Atlas and Oumuamua. In fact, this could be a real game changer in the world of ufology. I'm telling you, it really, really could. And it's quite complicated, so I'm going to get right into it. It concerns a scientist called Dr. Beatriz Villarroel. I'll just show you her here. This lady here, who is a I can't read that there, but anyway, she's an astronomer from Sweden, and I'll give you all the details in a minute when we read the paper. But this is basically, I'll give you a bit of background to her as well. But she's done a very interesting paper all about things that she has discovered. And I'll just go to my notes as always. She's a researcher at the Nordic Institute for Theoretical Physics in Stockholm, Sweden, and she's making some significant contributions to astronomy. She's currently running what she calls the VASCO project, and that stands for Vanishing Stars Multiple Transients, and I'll show you a bit about what she's been up to and about the kind of things she's been talking about. But she's not like I said, she's not kind of like some far out woo woo like me. She is like an accredited associate of the whole astronomical person area, just like exactly like Avi Loeb is. I mean, these are people who are not the kind of people you normally think would talk about these things. I don't think you'd ever find Beatriz Villarroel standing on some dark hillside at the dead of night in Wellington boots and a woolly hat with a camera pointing at the sky. You know, no offense, Win Keach, but she's not that kind of person. And she's got all these awards and recognitions. In 2012, she got the Crafoord Scholarship for Young Astronomers, Royal Swedish Academy of Sciences, 2022 won the UNESCO for Women in Science Prize for the VASCO project. Oh yeah, 2022 UNESCO for Women in Science International Talents, 2023 Heterodox Academy Open Inquiry Award for Courage. There you are. So yeah, I mean, when someone like this starts talking about weird stuff, the kind of things that we talk about, we loonies, we UFO wackadoos, I think it's important that some people sit up and take notice. And we're going to do a big deep dive into this paper that she's written here, which I'll show you. It's very, very interesting, and then cover a few other things that she said beforehand. So this is the paper. I'll just show it to you. And this is it. Aligned multiple transient events in the first Palomar Sky Survey. Right. I'll go through as many of these things if I can. If I hit something I can't understand, I'll look it up because this is in scientific language. So I might not be follow all of it. If you want to know what she means by Palomar Sky Survey, it refers to the Palomar Observatory, which is near San Diego, California, USA. And it's this thing behind me. That thing there. That's it. I decided to put that as my background. It's a big observatory founded in 1929 by the California Institute of Technology. And it's been used basically to do a big survey of the sky from the beginning. Now, you must remember that there were technically speaking, or what we've been told is there should have been no artificial objects in the sky at all until 1957, because that's when Sputnik was launched. Definitely. So if there's any weird stuff up there before Sputnik was launched, that's the first space rocket, you've got to ask yourself, how did it get there? So let's just look that up, shall we? Now, so this is it. So she's the lead author, Beatriz Villarroel there, see? Hickman Gogoni, don't know who he is. Rudolf E. Barr, Alok C. Gupta. And here's a whole list of different people. There's some more here. There's Enrique Solano. And one of the authors, I think, is Dennis Osberia, who is the guy who's been looking into the Baltic Sea anomaly. And she's now involved in this as well. Hope you can see all that. Is that visible? Good. Okay. And here's just, this is just the accreditations and the background to the various people involved. There's a huge number of people involved in this paper. And so it starts like this. Old, digitized, astronomical images taken before the human spacefaring age offer a rare glimpse of the sky before the era of artificial satellites, which is the point I just made. I'm not going to do a weird voice for this. I'll just sort of like look down when I'll look down when I'm sort of like reading the paper. I'll look up at the camera when I'm talking to you. All right, so I'm not going to do some weird voice. In this paper, we present the first optical searches for artificial objects with high specular reflections near the Earth. Now, the reflection thing's important because some people try to claim that these are little just marks of cosmic rays that have distorted the photographic plate, but it's not. I'll come on to that. We follow the method proposed in the Villarroel et al. 2022, that's another paper, and use a transient sample drawn from Solano et al. 2022. Now there's hyperlinks for these various things, but I'm not going to. If I start opening all these, it'll take me days to read everything. So we're going to stick to this one paper for now, and I have actually looked up some additional information that you need to know, which I'll come on to afterwards. We use images from the first Palomar Sky Survey to search for multiple brackets with plate exposure on close brackets transients that, in addition to being point-like, are aligned along a narrow band. Transients are things that just come and go; they just appear and then disappear, as a satellite would in a modern astronomical photograph, whereas as opposed to a star, which is there all the time. We provide a short list of the most promising candidates, including one with this symbol here, which I don't quite understand, but it refers to statistical significance. This means to do with whether it's a coincidence or not. Okay, we're going to come on to my coincidence rant with the skeptics, as I always do. As in previous cases, Villarroel et al. 2021, Solano et al. 2023, no known astrophysical or instrumental explanations fully account for these events. We explore remaining possibilities, including fast reflections from highly reflected objects in geosynchronous orbit, or emissions from artificial sources high above the Earth's atmosphere. Right. These are the remaining possibilities, as Sherlock Holmes said. When you've excluded everything else, whatever's left has to be the truth. And of course, when we're referring to reflective objects in geosynchronous orbit and artificial sources above the Earth's atmosphere, pre-1957, it can't be a satellite. Notably, the statistical candidates, that's the candidate we just talked about, coincides in time with the Washington, D.C. 1952 UFO flyover. Well, that's interesting, isn't it? You've probably heard about that. That's a very famous case where large and strange objects were seen in the vicinity of Washington, D.C. and picked up on radar. It's very, very interesting, that. And another... a something candidate falls, that's another statistic there, falls within a day of the peak of the 1954 UFO wave. Yes. Yeah. And the 1954 was a big year for UFOs. Big year indeed. It's one of the most statistically significant years. Indeed, my first UFO book, the Osborne one, talks about 1954. We also find a highly significant, and there's a minus, was it Sigma 2022, deficit of transients from Solano et al. 2022 within Earth's shadow. That's interesting. So basically what they're saying is that in the nighttime side of the Earth, in other words, well, I don't know if you have day and night in space, but when the sun is between you and the Earth, so that the sun is eclipsed by the Earth, there's a deficit. In other words, there are none of these transients then. And it says here, supporting the interpretation that sunlight reflection plays a key role in producing these events. That's true. Do you remember when I went with Rhiannon and Michael to Pembrokeshire and we did that sky watch? Do you remember that campsite? Do you remember that? And I was seeing satellites go over. They're visible because they're at an altitude in which the sun is still shining. So at night time we can see them because they reflect the sunlight. This study should be viewed as an initial exploration into the potential of archival photographic surveys to reveal transient phenomena, and we hope it motivates more systematic searches across historical data sets. So do I. So do I indeed. And this actually is a draft art. I mean, she was just Beatrice. If you follow her on Twitter, where is she on Twitter here? Just one sec. I don't want to show you what I've been looking up on Grok. Here we go. Let me just go back to Twitter now. I've been following her on Twitter. There we go. This is her on Twitter. She's actually been talking. This is actually a draft paper. This has not actually been published fully. It's still under peer review. But there's several different versions of this. For example, this is an article about her in La Tribuna del País Vasco. That's actually a Basque. It's a Spanish. It's a Basque newspaper. So the Vasco actually just means Basque. It's got nothing to do with the Vasco project. But this is the article that she's just been writing, or she just had written about her. You can translate this if you want. I did translate this about her in this Basque paper. But if you scroll down a little bit further, here we go. This is an updated version with additional shadow tests. Okay, so that's the version I'm looking at now. This one, you should be able to see this, and it hasn't. It's still under peer review. It hasn't actually been published fully yet, so this is still a draft. And it says here keywords: classical novae, right? And a nova is basically like a stellar nova when a star explodes. Ultraviolet astronomy, history of astronomy, interdisciplinary astronomy. All right. So introduction: digitized sky surveys have broadened the time window in which we can study changes in the sky. Programs such as Digital Access to a Sky Century at Harvard, DASH, that's the acronym, Grindley et al. 2012, and the Digital Sky Survey, DSS. Dignity Statement Stories. No, that's a gas banner reference. The Ukraine Virtual Observatory. All right. And there's Valilova et al. And Carte du Ciel. I think that means map of the sky in French. Provide images of the sky spanning not just a few decades, but in some cases over 150 years. How well can you read this, actually? It doesn't matter if you can't read it particularly, because I'm going to read it out for you, but it's nice if you could read it too. While photographic plates are no longer used for large astronomical surveys, having been replaced significantly faster and more sensitive CCDs, I think is that to do with electronics, I suppose, electronic photography. The archival images still serve important scientific purposes. For example, they allow studies of long-term variability of astronomical sources over timescales of decades or even a century, assuming the object is bright enough to be detected. Yes, and assuming that the photographic plate still exists, and that's an important point. We'll come on to that. Another use of these archives is to search for vanishing stars and other transients. Now, stars vanishing. I mean, stars do vanish at times when there's a supernova. I mean, there's just been a supernova. I don't know if you heard about that. I covered it in Space Weather, where a star actually did explode. It just blew up. Well, it was like a stellar nova, and it blew up, and now it's gone. It can't be seen anymore. I mean, there's still something there, but it's like a neutron star, which is not visible from the Earth without a very sensitive telescope. But the star itself is gone. It was actually, this happens quite regularly. Stars, like they go on for a certain amount of time, and then they have a stellar nova, which is like a huge explosion, or a supernova when it's especially big, and then they turn into neutron stars or black holes or white dwarfs. And it says here, in the vanishing and appearing sources during a century of observations. Oh, that's what it stands for. Vanishing Vasco. Yeah, via Vasco. That's Villarroel et al. And then that's, she actually did an interview with Ross Coulthart about this. Where is it? Here we go. This was a few months ago. By the way, Coulthart's gone a bit weird lately. Have you noticed? This one here. I won't play it to you. It's on News Nation. It's on his reality check show on News Nation. That was a few months ago. By the way, Coulthart's gone a bit weird lately, hasn't he? I mean, it's not only like that he says, I have absolute proof that, those Tic Tacs that the US Navy found in 2006. Well, I have absolute proof that they are from Lockheed Martin and they are secret technology. Well, and he said, I can't tell you, but that's what they are. And I'm like, oh, not again, Ross. This Jenga tower of bloody, I have this information, I can't tell you stuff. It's got to come down at some point. You can't keep building it up forever. It's a bubble that's going to burst eventually. But you know, how does he know that? It doesn't. There's many reasons to doubt that. And now he's coming out and saying, well, I'll come on to it later, but he's having a bit of a go at Avi Loeb. And he said, the Juno, because Avi Loeb's got this idea of sending the Juno spacecraft from Jupiter. It's an old craft it's finished its mission. They're just arranging to deorbit it into the planet, so it doesn't land on any of the moons. And he says, and Avi's got this idea of firing the spacecraft's engines one last time so it can intercept 3i Atlas as it flies past Jupiter in March next year, assuming that 3i Atlas stays on that trajectory. And Ross said, what's the point in doing that? What's the point in wasting the fuel and such a valuable spacecraft on something that really doesn't matter if it's just a comet? And it's like, it's just weird. I mean, Avi actually takes him up on his blog. I can show you the article later. I'm going to come to Avi's blog later anyway. But I mean, what is up with Ross? What the hell is up with him? I mean, why did he say that? Why did he say? I mean, firstly, as I just explained, Juno's completed its mission. As I said, it's just a pile of junk now. NASA are just trying to arrange ways to deorbit it now, which is planned for very soon. Why not let it go out with a bang and let it serve one more vital purpose? And look, even if it turns out just to be a comet, all right, it's still an interstellar object and it's an interstellar comet, and you could learn an awful lot by getting a close look at it. Oh, I don't know what's up with Ross. Ross is losing it a bit, I think. He's changed, and he's not the only one, is he? All right, and back to the paper. Right. Yes. Blah blah. Where was I? Yes, Vasco. Right. Project images of the sky taken in the 1950s, prior to the first anthropogenic satellites, are compared with modern surveys to identify possible sources that may have disappeared. Vasco employs two complementary approaches. First, an automated procedure, Solano et al. 2022, that searches digitized image data from the first and second Palomar sky surveys, that's POS1 and POS2, for transients. And second, a citizen science project. And, you see, the experts don't like the word citizen. It's like citizen journalist, citizen this and citizen that. They don't like that. But, well, she doesn't mind, which is good. This is where volunteers classify potentially interesting objects. These efforts are facilitated by the Spanish Virtual Observatory and its software tools. The Vasco program has resulted in the cataloguing of many thousands of unknown transients visible only within a single plate exposure. All right. Many thousands of unknown within a single plate exposure. That's amazing. You saw there was some in the title slide I showed you, and I'll come on to them. The title shot. A particularly intriguing finding from the Vasco project was presented in the Villarroel et al. 2021. 9 faint star-like objects that appeared and vanished simultaneously on a 1950s POS1 plate. These transients were not visible on another plate taken half an hour earlier, nor on a third plate 6 days later. Half an hour? That's weird. So they appeared within half an hour and then just disappeared. All known astrophysics explanations were considered but deemed implausible. Yeah, how do you explain that? The surface density of such transients was too high to be attributed to any known natural phenomena. The surface density. Oh. How do they know what density it is? Is that just like an astronomical term? Whether this was due to unknown contamination on the plate with coincidentally star-like defects. Oh, the skeptics are going to jump on top of that one, you can bet. Or a genuine astronomical observation remains unsolved. Well, the skeptics right now they've already decided what it is now. They've already decided that it's that. But you just imagine the coincidence, though, that it's necessary for that to be accepted. And of course, the skeptics will accept that coincidence. They'll accept any coincidence, no matter how unlikely, other than having to conclude that it's aliens. If real, One explanation could be that they were caused by solar reflections off flat, highly reflective objects in geosynchronous orbit. Wow. Around the Earth. What if that's I like that black night thing, that Billy Carson talks about? If correct, this would represent a significant discovery with far-reaching implications for both astronomy and humanity. Yeah, not half. I mean, including the possibility of non-terrestrial artifacts, NTAs. So we've got another word for it now. We've had UAPs, we've had NHI, now we've got NTAs. We've got to settle on one of these at some point. But yeah, of course, the far-reaching is an understatement. I mean, obviously, when it comes to NTAs or UAPs or NH, whatever you call them, of course, we know they're here. We know they're around. We know they're not only out in space, they're down here on the Earth with us. They fly over our heads all the time. They're seen every day. But this is proper science being done about something in space, which maybe I'll come on to this at the end. I'll come on to this point at the end. But the very fact that this has been treated in this way through astronomy is a game changer. I'll come on to more. I'll say more about that at the end. It also bears directly on the scientific investigation of unidentified anomalous phenomena, UAPs, yeah, formerly known as unidentified flying objects, UFOs. Well, I still call them that. I still call them UFOs. I'm a traditionalist. A subject that, after decades of stigma, is now gaining serious academic attention. Told you so, na, 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 na. As highlighted in the recent review by Newth et al. Oh, right. That's not Kevin Newth, is it? All right. In Progress in Aerospace. All right. Clarify. I'll look that up later. Clarifying the origin of these transient events is therefore not only of astrophysical interest, but also of potential importance for one of the most enigmatic and consequential questions facing science today. I love, she's very good at the understatement, is Beatriz. She really is. To add to the intrigue, Solano et al. 2023 recently reported a bright triple transient event occurring on the 19th of July, 1952. That's around the time of the Washington event, isn't it? And found a set of Sigma 5000. What is it? I think that's Sigma. That's that little squiggle. I was looking up a thing about the statistics. But anyway, I don't understand that bit. But it's a short-lived POS1 transient. Right, a set of these, Solano et al. 2022. As in the earlier case, the objects appear and vanish within a single 50-minute exposure. Their brightness, and it says there how bright they are in an equation, makes contamination less likely. Notably, this particular event coincides in time with one of the most extensively documented aerial anomalies in the historical records. Yes, as I just said, the Washington, D.C. UFO flap of July 1952, which unfolded over 2 consecutive weekends, July the 18th and 19th, and the 26th and 27th. Yes, it's nice to know the aliens thought there's no point in us appearing during the week because all these humans will be at work. So let's just pop out Saturday and Sunday when they're all out and about, shall we? Yeah. While this may be a coincidence, the skeptics are going to say it's definitely a coincidence. The temporal proximity invites further scrutiny. In other words, timing. Temporal proximity. Especially given the rarity of both phenomena. Not so rare, not that rare, Beatrice, not that rare for the UFOs. In a separate study, Bruel et al. Submitted, we investigate possible statistical associations between historical UAP reports and Vasco transients. Ooh, right. And find preliminary evidence of a temporal correlation and there's the statistical level. Temporal correlation, again, means timing at the same time, coincidental, synchronous, whatever that is. While such a finding does not imply causation, it raises the possibility that certain anomalous aerial observations recorded in the pre-satellite era may have had physical counterparts observable in deep sky imaging. Yes. You see, if I'm out walking in a thunderstorm and a lightning bolt lands on my head, right, and I happen to have a taser in my pocket, you know, and I suddenly burst into flames and like turn into a pile of ash. You know, there's not necessarily, I can't necessarily imply causation there. It could be the taser just went off. All right, you know, the fact that a lightning bolt hit my head doesn't imply causation. You can't prove that lightning bolt caused me to burst into flames and turn into a pile of ash. You can't prove that. And you know, I'm sure a skeptic will say it was just coincidence. These bloody lightning theorists. Honestly, every sensible person knows that it's a taser. It's the taser in your pocket, Ben. Yeah. All right. While such a fine, all right, possibly certain observable. All right. Yeah. Where did I get to? Pre-site era may have. It raises while it's not implied causation, it raises the possibility that certain anomalous aerial observations. AAO. That's another one. AAO, anomalous aerial observations. Let's have a comment, please, for AAOs. Recorded in the pre-satellite era may have had physical counterparts observable in deep sky imaging. Given the unusual nature of these events and their potential implications, it is important to further test the hypothesis. Not bad grammar. It's further to test or to test further. Well, she's Swedish. I can't be too. I can't be too much of a bloody pedant because she's Swedish. Hypothesis that some transients may originate from reflective artificial objects in Earth orbit. Searches for extraterrestrial probes were proposed as early as the 1960s. Bracewell, 1960. But to date, only a few searches for NTAs, non-terrestrial artifacts, have been attempted or proposed. Freitas and Valdez, 1980. Valdez and Freitas, 1983. Hack, Misra and Paponu, 2012. Right, yeah. So that's essentially connected to the whole SETI thing, you know. And a previous white paper, Villarroel et al. 2022, proposed a methodology to search for solar reflections from artificial objects in geosynchronous orbit using photographic plates from before the satellite era, pre-1957. Now, I know some of you are going to say, well, what about the secret space program, Ben? All right, well, again, you've got to ask yourself why these, if we did have secret space program back then, that they were appearing like in these plates and then disappearing. Why were they doing that? And also, you know, they go back much further than that as well, as you know. They go back to long before we even invented piston engine aircraft or even balloons. And I've covered all this before, how this, you know, the secret technology does not explain the entire UFO phenomenon. It doesn't. And when you put it into the context of what Beatrice has found and her colleagues have found, then I think there's something a little bit more going on. I don't think this can be explained as the secret space program. One key signature is the presence of several point-like transients that are aligned along a line within a single exposure. A statistical framework was also developed to assess the significance of such alignments. Now, this is actually very important because Beatrice has said several times she believes these objects appeared in formation. In this paper, we carry out that test. We apply the published methodology and statistical framework to a published sample of POS1 transients from Solano et al. 2022. We also identify several promising candidates and examine them in detail in section 5. Ooh, assuming the events are real, well, why wouldn't they be? They're there in black and white, literally on photographs that, you know, are not there. These are not copies. They got the original plates, those that weren't destroyed. I'll come on to that later, that some were destroyed. We use the aligned transients to infer the possible geometry and surface density of reflective objects near geosynchronous orbit. Wow, that's amazing. So they were talking about structures here. We also perform a statistical test to evaluate whether sunlight is required to produce these transients based on their detection rate within the Earth's shadow. Well, yeah, I suppose if they are not in the umbra, that is the part of the space that is where the Earth eclipses the sun, and they're not there. Presumably, they don't have internal light. They are reflecting sunlight. Finally, we discuss prospects for detecting similar objects in modern digital sky surveys. Oh, that would be fascinating, because I mean, I've often said this is where I essentially have to eat my words a bit, because I did say at one point that cover-ups are impossible in astronomy. Astronomy is the one truly democratic science. The data is all above our head. It cannot be hidden. There are just so many telescopes in the world. There's too many astronomers, amateur and professional, that it's a flow of information that basically cannot be stopped. I mean, compare it; they cannot actually be intercepted and stifled. If you compare it, for example, to a UFO crash retrieval, which is very different. A UFO crash retrieval is a strictly local affair. If a flying saucer crashes somewhere, you just seal off the area, remove the physical evidence, come up with some weather balloon story, and that's it. That's it. Bob's your uncle. But we're talking about things everyone can see above our heads. Anyway, number 2, plate defect or techno signature. Right. This has to be, the idea of a plate defect or something else has to be eliminated. So let's have a look. One of the core challenges in our work is the contamination of photographic plates by artifacts that may mimic astronomical sources. So, like the spider crawling on the lens, that does happen, believe it or not. Apparent transient events of these plates often present a case of degeneracy, where genuine astrophysical signals and mundane defects can appear strikingly similar. Now, this is a bane of radio astronomy, as you know. If you watch my SETI talk and watch anything about SETI, actually, the search for extraterrestrial intelligence, you'll find out all about it. Certain plate defects are known to resemble stellar profiles, Grenier et al. 1990, and distinguishing them from authentic observations remains a non-trivial task, even when full width half maximum FWHM comparisons are applied. In other words, it's hard work to do that. Moreover, defects can cluster near plate edges, and vignetting or uneven development may further confound interpretations. That means basically it's like sand in the camera, when you're on the beach. Oh, it's a bit of sand in the camera, you get weird, the photos come out badly. Moreover, defects can, I've read that bit. Nevertheless, visual inspection and photometric profile analysis remain indispensable tools in this early phase of exploration. It is scientifically untenable to assume that all candidates are either authentic transients or all defects. Well, I think a skeptic would disagree, and they say it is perfectly scientifically tenable to claim that all candidates are defects. I mean, I'm sure Jim Skin Pivot and David Smith are saying that right now as they're watching this in the comments section right now. A reasonable working assumption is that both populations are present in some unknown proportion. From this perspective, even single authentic detection among many contaminants would validate the effort and warrant continued search. Absolutely. This is the same with crop circles. I mean, in fact, this can be applied directly to crop circles. And indeed several other things. Basically, if you're a skeptic, you realize you have to be right every time about every single case. We woo-woo wackadoo circle jerkers, okay? We only have to be right once to prove our point. Right, here we go. This degeneracy is intrinsic to any attempt at identifying non-terrestrial artifacts, NTAs, in archival material. 2 primary examples illustrate this problem. Narrower FWHMs and rounder profiles. It said earlier what FWHMs was. I'm not going to look that up again. Anyway, they interpret slightly more concentrated round profiles as signs of spurious detections and makes an example with Villarroel et al. 2021. However, atmospheric, seeing, and short-lived sub-second to a few second optical events are also expected to produce narrower FWHMs than long exposed stars. Thus, profile sharpness alone cannot conclusively distinguish between artifact and astrophysical origin. Right. I think that refers to what objects your natural celestial bodies look like compared to something like a satellite or something like that. I think that's what that means. Spatial distributions. A high surface density of transient-like features. Again, that sounds to me like they're talking about structure. In a given region may suggest poor plate quality. Right. High surface density of transient. All right, so that's if you get lots of marks and errors on the plate. Yeah. But the number density of transients on a plate is not diagnostic. If NTAs exist in coordinated swarms, these swarms could span tens of square degrees, easily covering entire plates. In ambiguous and uncertain cases, such as the plate analyzed in Villarroel et al. 2021, additional transients or artifacts may surround the nine candidates. See supplementary information. Maybe I should write. I should see if I can. Can I? No, I can't. I can't access that. I mean, I can't keep going down these. Like, look at other papers right now. I think I know what she's referring to there, and I'll come on to it in a minute. Because of the ambiguity in these cases, we advocated for more targeted searches in Villarroel et al. 2022, emphasizing particularly multiple transients along a line where statistical analysis can decisively test whether such configurations occur by chance. So she's like looking at things that form a pattern, which are less likely to be just damage and just marks on the photographic film and stuff like that. The problem with that is that the skeptics then will jump on that and say coincidence. That's the problem with that argument. I mean, she probably knows this already. She's had to deal with skeptics all the time. Moreover, the temporal correlations between the 1950s transients and both the Washington 1952 UFO events and the 100 and 124 US, Soviet, and British nuclear weapons tests deserve serious attention. Wow. Nuclear weapon. I mean, as you know, if you've watched UFOs and Nukes or read the book UFOs and Nukes, you'll know that if there's one pattern of behavior we can glean from at least some of the ETs is their interest in our nuclear weapons. There may be several reasons for this, both optimistic and pessimistic, but which I won't go into now. But they have it's very interesting the way they seem to hang around nuclear bases. I myself, as you know, if you're a regular viewer, I took a photograph when I was hiking in Scotland in 1998. And on the photograph, you can clearly see a flying saucer. Now, I didn't see anything at the time, but it appears on the film. Even if individual events remain uncertain, Bruhl and Villarroel 2025 shows significantly correlations between the subsets of the transient sample in Solano et al. 2022 and historical nuclear activities and aerial anomalies. This alone contradicts the idea that the entire sample consists of plate defects. Yeah. Although someone will say coincidence, like I said. Finally, one of the most revealing tests involves Earth's shadow. No matter how asymmetric or irregular the distribution of plate defects may be, they have no plausible reason to avoid the Earth's shadow. Except it's a coincidence. In contrast, transients associated with solar reflections would. That's true, actually, because if it's in the umbra of the Earth, eclipsed, where the sun is eclipsed, it would be in permanent darkness. And unless it had an internal light source, you wouldn't be able to see it because there'd be no reflection. The shadow test provides a crucial empirical lever to distinguish between physical reflections and random defects and remains an essential part of any validation framework moving forward. In this paper, we rely on hypothesis testing across large samples, assessing statistical correlations, spatial alignments, and Earth shadow sensitivity, offering a robust framework that remains valid even in the presence of substantial stellar-like contamination. In the future, we aim to use AI-driven methods to filter out transient that resemble plate defects or occur in the problematic regions of the plates, and to establish an upper limit on the fraction of objects that may represent NTAs. Oh no, please don't do that, Beatrice. Don't use AI, for goodness sake. AI is useless. AIs can't even read a bloody bus timetable properly. All right, for now, we will use the simplest methods to search for candidates that show signs of solar reflection. Okay. Predictions and expectations. Number 3. Natural transients occur at a rate several orders of magnitude lower than glints from artificial objects. Natural transients occur. So what would a natural transient be? A meteor, something like that? Even detecting 2 natural transients within a few arc minutes of each other during a 1-hour exposure is extremely unlikely. Right? Yeah. Arc minutes actually doesn't refer to time; it refers to distance it refers to a 60th of a degree. A 60th of a degree is an arc minute. Is extremely unlikely. So that would be like meteors, I suppose. In contrast, glints caused by solar reflections from flat, highly reflective surfaces at high altitudes, such as geosynchronous orbits, could result in multiple simultaneous point-light transients during a single long exposure image. If the glints originate from the same object, they may appear aligned along a narrow band or straight line. So, I see. That would be if something is like moving in geosynchronous orbit, and it would glint at certain points along that route in a long exposure image. Yeah, I get it. And again, there shouldn't be anything in orbit before Sputnik apart from the moon, basically. In simple geometrics, the glints could be equidistant and of similar brightness. However, more complex surface structures may lead to irregular spacing and variable flux. Yeah, a bit like a Muamua. Also, objects flying in formation or coordinated swarms might be found along geomagnetic patterns. Yeah, she says that some of these things are in formation. Multiple transients in a single image are frequently detected in modern automated surveys. Are they? What? Multiple transients in a single image are frequently detected in modern automated surveys, are they? Where? This isn't just something that happened in the 1950s. It's still happening now. You'd think astronomers would say more, wouldn't you? Nearly all transients with duration shorter than 0.5 seconds are caused by this phenomenon, often originating from satellites or space satellites or space debris. Corbett et al. 2020, Near et al. 2020. These events typically have apparent magnitudes of something so much. That's how bright they are. The rate of such artificial glints can reach some 1,800 events per hour near the equator, which would overwhelm any comparable phenomena in modern surveys unless specifically targeted. So really, the problem now is you can't tell between if you can't tell when you see something in the sky that's transient, it could just be a satellite, because there are so many satellites up there, thousands of them. The red POS1 plates reaching something magnitude with a 50-minute exposure are still capable of detecting glints as short as 0.5 seconds. That's back in the early 1950s. Although the flux is diluted by approximately 9 magnitudes. All right, so that's differences in brightness. Plate defects, by contrast, are expected to be randomly shaped and distributed. The chance that several defects simultaneously mimic star-like point sources and align along a narrow band is small. Could still be a coincidence, though. The method proposed in Villarroel et al. 2022 identifies simultaneous transients that appear within the same long exposure photographic plate and are additionally aligned within a narrow tolerance. Right, I'm not sure quite what that means. Narrow tolerance. Simultaneous transient appear on the long exposure plate. Okay. This alignment criterion helps distinguish potentially artificial signals from random celestial or instrumental sources. Right. Well, I don't quite understand that bit, but it's always good if you have a method for sorting the signal from the noise. For example, an image with 9 transients inside a 10 by 10 arc minute squared box may exhibit a 4-point or 5-point alignment with a statistical significance between 2.5 something and 3.9 something, depending on the geometry. For exact probabilities, we refer to the readers to Section 5 in Villarroel et al. 2022, which uses the statistical framework developed by Edmonds 1981 and Edmonds and George 1985. Even 3-point alignments may be considered when the total number of transients in a region is low. Alignments with the lowest probability of occurring by chance should be prioritized for further examination, though not interpreted as conclusive evidence of geosynchronous reflections. Well, that makes sense, doesn't it? You can, if there's that amount of data, you need to work out which is the one that's worth further studying, which is not. Taken together, these considerations show that the occurrence of aligned simultaneous transients on photographic plates is an excellent candidate signature of reflected orbital objects, especially in the absence of natural or instrumental explanations. So, yeah. So again, this is statistical analysis, yeah. While alignments of multiple transients provide a statistically robust signature, it is important to note that most glints caused by solar reflections are expected to appear as single isolated transients on a photographic plate. This follows naturally from the geometry of specular reflection. Specular is where you get like a really, it's not just like like light going in every direction, it's going in a single direction. I know that from the moon landing stuff. Where a glint is only visible when the orientation of a rotating object briefly aligns with the observer and the sun. Yeah, we saw that with Oumuamua, where sometimes it'd be very bright, then it would go down because different parts of it were reflecting the light. Assuming a large population of such objects in geosynchronous or higher orbits, the majority of events will not repeat and will appear only on a single plate only. These point-like flashes may still exhibit perfect PSF shapes, PSF, and are typically absent in Earth's shadow, further distinguishing them from both natural and instrumental phenomena. Although individual transients carry less statistical weight, the overall rate and behavior of such events can still be used to identify a non-natural origin. As shown in Villarroel et al. 2022, statistical models incorporating both aligned and non-aligned transients offer complementary routes for detecting technosignatures in historical data. So again, it's whether they appear in formation or not. Yeah. Methods and selection. We base our analysis on the catalogue 298165 short duration transients presented in Solano et al. 2022, detected in red POS1 plates with typical exposure times of 45 to 50 minutes. These transients were identified using an automated pipeline developed as part of the Vasco project. Right. So this is the kind of methodology that people need. See, this is the thing. Very often people like Beatriz and Avi Loeb, they invent ways and means of actually doing this, and they don't always get thanks for it. And that's typical. Eh? For full details on the detection methodology, data characteristics, and vetting steps, we refer the reader to Solano et al. 2022. From this data set, we search for spatial groupings of transients within square boxes of varying sizes, typically ranging from a few arc minutes up to 20 to 30 arc minutes per side. 30 arc minutes will be a third of a degree. See the size in table 2. All right. For each right. Now we've got like we've got a footnote here. Number 3. Where does that come from? Where's that references for? Anyway, it says here we consider the probability of detecting a transient within 1 hour of a POS1 in the POS1 survey, based on a Solano et al. 2022, who identified 298,000 transients over 780 hours of exposure. Go do the maths and see how many that is. The chance of finding one transient in a 10 arc minute squared box in 1 hour is approximately 0.0016. The probability of 2 such transients appearing in the same box is then, and it's a p-value to the 10 to the minus 6, so very, very unlikely indeed. I think that means p-value, something like that. Table 1, candidates. Total number of aligned transient candidates identified by each sky region is the number of aligned points. Right, now I don't actually understand this particularly, but it's like a table or graph of like an adding graph. And it says here, we go back up here. For each group, we evaluate whether the positions of the transients fall along a straight line or more precisely a narrow band within astrometric uncertainties. We quantify the degree of alignment using the Pearson correlation coefficient between right ascension and declination. We retain only those candidates' alignments which are something greater than 0.99. I don't know what that means. Or the Pearson correlation, which is this symbol here, which is alpha, I think. Alpha greater than 0.99. So again, that's using, it's a filter. We note that the correlation is computed without applying this correction to the right ascension. Given the small angular separations involved, this has a negligible effect on the ranking candidate alignments. What you can already see now, can't you, that the skeptics are going to attack this based on what they will see as mistakes in statistical mistakes. That's what they're going to do. And it's called, so table 1 summarizes the number of aligned groups found within, respectively. Because the search boxes vary in size, the number of transients per group is not directly comparable across cases. All 83 candidates are presented in the appendix. Visual inspection reveals that duplets and triplets are relatively common. Right. So that's 2 or 3 together. However, rather than evaluate every alignment within n is greater than 3, we focus on high confidence candidates with at least 4 aligned transients. Many POS1 plates have been scanned by both DSS and Supercosmos Sky Survey, Hambley et al. 2001. Since Supercosmos Images, I don't remember that comic book. Anyway, is that part of the Marvel universe? Supercosmos Images generally offer high spatial resolution. That means, I suppose, they're good quality images. We used both sources to verify each alignment. We downloaded FITS images for all candidates with n is greater than 4. I'm afraid I don't know what all this means. Selecting image boxes that encompass the full alignment. In several cases, transients initially appeared as point sources in DSS were revealed though through Supercosmos images to be either scanning artifacts or round defects likely caused by emulsion flaws. All right, yeah. Again, you've got to. This does happen, and I suppose Beatrice and her colleagues want to bulletproof this against the kind of easy low-hanging fruit the skeptics go for, and I understand that. Transients absent from the higher resolution scan were excluded for further consideration. From further consideration, we thus retained only the candidates that 1 show at least 4 star-like transients in a roughly linear alignment on the DSS scan. 2 are confirmed by the corresponding Supercosmos scan. The DSS and Supercosmos scans are independent digitizations of the same physical photographic plate, obtained using different scanners, optics, and digitization procedures. This means that any object visible in both scans is almost certainly a real feature present on the plate emulsion. Right? Oh, that makes sense. That's they just want to rule out the possibility that the processing of the image for the digital analysis creates these images. In contrast, an object visible in only one of the scans is most likely a scanning artifact caused by dust on the scanner glass, digitization noise, or compression effects, not a genuine plate defect. We therefore treat agreement between both scans as a strong indicator of authenticity. Furthermore, we note that some objects that initially appear point-like in DSS images may exhibit subtle asymmetrics or deviate from a stellar PSF in the higher resolution Supercosmos images, leading us to reject them. Yeah. I don't quite understand that bit. This procedure helps ensure that the remaining candidates are not spurious artifacts introduced during digitization. From this refined set, we identify 5 of the most promising candidates in the Northern Hemisphere, listed in Table 2. There are 2 key ways the search procedure could be improved. Search area. Objects in geosynchronous orbit move at something arc seconds or about 10 degrees during a 50-minute exposure. Our current box size up to 30 arc minutes is conservative and may miss longer alignments. Correlation threshold. The criteria, which is this Pearson thing here, being greater than 0.99, is unnecessarily strict and excludes mildly curved or non-ideological alignments. However, relaxing either parameter would drastically increase the number of candidates, potentially into the tens of thousands. Increase the number of candidates potentially into the tens of thousands, necessitating substantial manual vetting. Right. So they're basically saying sometimes you just have to think, well, there's lots of them here, and we need to sort of like think them over ourselves. There's no automated system for dealing with this, or no kind of like a flow chart you can just use to go down without looking at it yourself. Sometimes you just have to use your intuition. To address this, we're developing an expansion of the Vasco citizen science platform tailored to this task. Citizen science rules. The shortlist. Right. The shortlist in Table 2 shows the candidates. Each candidate is shown in figures 1 to 5. Here we show only transients themselves to assist the reader. We show, right, the same images but showing the actual alignments can be found in figures 7 to 11. The alignments differ in width. Therefore, a dashed double line is shown in some particular cases where the width of the stripe is larger than 1 arc second. And an arc second is a 60th of an arc minute. In some cases, for example, the objects marked with crosses in candidates 3 and candidate 5, it is not certain that every transient is a point source based on inspection of the images. Slight asymmetrics in the light profiles are presented in a few cases. Manifesting as mild elongations, e.g. from movement or qualitative irregularities in shape. Right, that's interesting, because that is what Avi Loeb is using to criticize the astronomers who say that 3I Atlas is a comet. He said that this could be caused by mild elongations from movement or qualitative irregularities in shape. And he also says that it's caused by photographic smearing. Therefore, the alignment is possibly a combination of transients and plate defects or objects in the sky within our atmosphere. Oh, balloons, birds. The reader can inspect the high-resolution images from supercosmos. We improve the astrometry. Is that a word? From the images using the TerraPix S-warp procedure. TerraPix S-warp, I love that word. We measure the improved coordinates and the FWHM for each transient. See Table 3. The dates are taken from the something plate server, DSS plate server. In a few cases, it's possible to derive more than one variant of the alignment, for example, with either 3-point or 4-point alignment. In such cases, we show both options separately in the images in figures 7 to 11. For the cases in the shortlist, we estimate the possibility of a chance alignment. Statistics. The section below provides a brief recapture of the statistical framework developed in Section 5, where interested readers can explore the details of the framework. For each of the interesting cases, consider the total number, n, of transient-like objects in the image field, and i.e. the area A of the image, and look for R objects aligned within the strip within Pmax and length Dmax. Such alignments will be referred to as R-point alignments. As the area A is different in each case, we can only estimate the number of R-point alignments. I'm afraid I don't understand this bit at all. This looks like complicated mathematics. Where something, I'm going to have to skip that bit. I'm sorry. Yeah, to calculate the number of. Yeah, the probability the probability estimate. I've skipped that little bit, I'm afraid. The probability estimate is also very sensitive to the total number of transients present. This number depends strongly on the visual inspection that was made by blinking the POS1 and POS2 images and they're talking about the process, the SAO image DS9, taking into account the differences in depth. Any missed transients will change the value of n, and hence the estimated probability. Of course, yeah. However, the estimate exactly the total probability of each event to happen during our searches, two more factors influence total probability. The first is the probability for obtaining a perfectly 1, 2, or n star-like plate flaws within the same area of the image, given the rarity of encountering a star-like plate defect, and even less so when with a matching FWHM, as the normal stars of the same magnitude range in the field. It may be even more unusual to encounter 2, 3, or 4 plate flaws that all have the same coincidental features, and this lowers dramatically the total probability of the event. And there's these footnotes here, which I'm not going to read out now. I'm not going to go into now. The second factor is the total number of multiple transients in our data set. If there are sufficiently many star-like plate flaws causing multiple transients, some of these will line up. With an infinite data set, any type of constellations will be found. Is constellations the right word for defects? This factor will, contrary to the first factor, increase the total probability for an event to occur. Unfortunately, we have no grasp or means of estimating either of the two factors. Therefore, it's easier to examine the effect of the choice of whatever on the probability estimates of a single image. The choice of something depends on the science question of interest. Are we interested in whether the objects are truly aligned or whether they are just non-random? Showing the, well, isn't that the same thing? maybe I missed something. Showing non-randomness is all that is needed to argue for the authenticity of the points, but not necessarily enough to argue that they are aligned in the case of GSO glints. Well, I don't know. If they're non-random, then presumably they're in some kind of formation, are they not? We use table 3 to adopt other values, setting it equal to FWHM of the smallest star in an alignment. Doing this, we see that all 3-point alignments are non-interesting events with a P greater than 0.05, less significant than with an exception of the borderline in the case of candidate 2. This shows that for POS1 data, where the seeing in general is rather large, 3-point alignments and simultaneous transients do not provide significant proof against randomness. The interesting cases are the 4-point and 5-point cases, namely candidates 3, 4, and 5. Yet one could argue that without an inspection with a microscope, one still cannot exclude plate defects. Right. If you can find the plate, we'll come on to that later. However, what makes the events even more interesting is that candidate 5 occurs on the same date as one of the most famous UFO mass sightings in history, namely the 1952 Washington UFO flap. This could be a coincidence. Yay! Well, it could be that you're seeing the same objects up in space before they descend onto the Earth. We also note that candidate 1 occurs within a day of the peak of the 1954 UFO wave. We shall discuss this further in section 10. These additional 2 coincidences further motivate scrutiny of the plate defect hypothesis, especially in the light of the combined statistical and contextual factors present in the study. Well, obviously, the skeptics are going to just say we don't care, really. Now, it gets more interesting when you see the pictures, but these are just the details of the various candidates. 7, assessment of conventional explanations. Thank you for not saying rational explanations. Oh, I have a real bugbear with that, don't I? The central challenge of this work lies in determining whether the transients represent authentic observations. Of course, that goes without saying. Yeah. A previous analysis of the multiple transient event in Villarroel et al. 2021 ruled out all known astrophysical origins and most instrumental causes as well. What remains is the possibility of unknown plate contamination or emulsional defects that coincidentally resemble star-like shapes despite their variation in brightness. Now that's a bit like what Anthony Peake talks about when he talks about promissory materialism. He used the thing which said, well, he challenges the skeptics who say things like, well, we can explain things like consciousness and the near-death experience as brain function. We don't quite know now, but we will in the future when we learn more about how the brain works. So I'm sure we're just 1 or 2 breakthroughs away from solving this problem and therefore basically defeating dualism and the whole idea of spiritual reality. You just wait. The next breakthrough will prove it. And as I've said, people have been saying that since neurology began in the 19th century. They're saying, well, maybe in 10 years' time we'll know more, and therefore we'll be able to disprove what these woo-woo wackadoos are saying. And this is similar. She says here, the possibility of unknown plate contamination. So there is a possibility there's some kind of contamination that no one's thought of yet, but it might still be there. And this is kind of like skeptical superstition, Well, there is an explanation for this. We don't know what it is. There's a rational explanation. There's a non-woo-woo explanation for this. There is a conventional explanation, to use the language of this paper. We can't see it, but we just know it's there somewhere. It's out there. Anyway, the skeptics are exactly what they say they hate. So yeah, and this is the same thing basically what she's describing here. While gravitational lensing by a short-lived transient passing behind an undetected supermassive black hole was SMBH. It sounds like some kind of porn, something to do with pornography. Yeah. Was proposed by Solano et al. 2023. Such a model would require an implausibly large population of undetected SMBHs in the Milky Way. I'm glad to explain the broader set of events found by Vasco. God, yeah. I don't want that many of these supermassive black holes around because we'll probably fall into one at some point. The phenomenon remains unresolved, now made even more intriguing by the discovery that several events are aligned along a narrow band. A potential concern is optical ghosts. Woo! Ghosts typically, that doesn't literally mean ghosts, by the way. They typically exhibit extended or clumpy morphologies and do not match stellar point spread fluctuations, PSFs. Oh, that's what that means. In contrast, the transients identified by both Villarroel et al. 2021 and the this is what you see now is another diagram here. Which again, I'm not going to go into in detail. All right. But, this is more interesting, you see, because this is the pictures. I'll just finish the sentence I was going to talk about here. Where is it? Here we go. Current study were pre-selected based on their PSF-like properties, making classical ghosting an unlikely explanation. Okay, so now let's go through these pictures. It always gets more interesting when you get pictures, doesn't it? For us non-scientists, where's the pictures then? We want to see a book with pictures. You see quite clearly here, indeed I'll include some of these images in the title shot. Here you see quite clearly there are some objects here in this plate, and on this side there are none. They're not there. You see, they're circled. There's one there. There's one there. You see, which is not present there. The pink ones are the ones that are present in this plate and not in this one, and the blue ones are the one that are present in the left plate and not in the right plate. Do you see what I mean? They just disappear. And it says here, we show the candidate in supercosmos scans of POS1 red left and POS2 red right images. Transients are marked with blue circles. The candidate with a measured coordinate is marked with a cross. Right. Oh, there's the cross there, you see. You see the cross. Maybe you can't quite pick it up, but there's a cross around that one. Pink circles show defects. Oh, I see. Right. Okay. The pink circles are not ones that are... See, the pink circles are defects that are... That's why they're not present in these plates. They're not objects that are not... They're there but not there. Transients. They're actually defects. Okay, I understand now. Also, the grey line crossing the POS1 field is a scanning defect. That's this line here. 4 transients are visible in the POS1 image, where 3 follow in a straight line. Is that the 3 in a straight line there? Box size is 10 by 10 arc minutes. See figure 7 for a version of drawn lines. Okay, candidate 2. Oh, see, there's even more here. There's 4 in this one, and there's the defects. We show the candidate supercosmos as POS1 red left and POS2 red right, images inverted. Transients are marked with blue circles. Again, it's the same thing. And there's the cross over the candidate. That's a big one, isn't it? That's a big bright one there. Yeah, it's a bright one. 4 transients are visible. Yeah. See figure 8 for a version with lines drawn that show possible alignment. Then it's the same box size. Whoa, what's this? Candidate 3. There's some really big bright ones here. We show the candidate in the supercosmos scans of POS1 red left and POS2 red right images, inverted. Transients are marked with blue circles. Oh, that's a defect, the pink one. Okay. The candidate with the measured coordinate is marked with a cross, which is that one there, not present there, and maybe slightly dubious in shape. I can't see its shape. Pink circles show defects. That unfortunately is a defect, that big bright one there. Both plate and scanning defects. Okay, so this is candidate 4. Whoa, look, there's the cross there on that there. Do you see how they're missing there? There's the cross and there's these things here. And there's another one there. There are no pink circles on this, so no defects. And we see the same, that's the same details there in this box here. Candidate 5. And again, I'm not going to read out these instructions underneath because it's exactly the same. But you can see here, these are big bright ones here, and there's 2 together down here. There's a cross there on that one. While most optical ghosts appear extended or irregular, one might ask whether more unusual ghosting patterns, such as point-like reflections, could in principle occur. Modern CCT-based surveys using the same telescope have documented rare ghost patterns that under specific optical conditions can mimic point sources at significant angular separation from their parent stars. Would that be like sundogs and things like that? Is that what that means? However, the applicability of such mechanisms to mid-20th century photographic plates remains uncertain. The optical layout, coatings, and mechanical tolerances of the Palomar 48-inch telescope that's behind me have changed substantially over the decades, and detailed documentations of the original POS-1 configuration is lacking. Moreover, the photographic emulsions used exhibit non-linear response to grain-dependent morphological effects, which complicate direct comparisons with CCD-based ghost signatures. Right. So that's talking about the chemistry of the actual photographic plate itself. To our knowledge, no documented case of point-like ghost reflections exists in the photographic plate material. A dedicated optical modeling effort would be required to evaluate such hypothetical scenarios, but given the lack of documentation on the optical system used during POS-1 and the absence of known PSF-like ghosts from photographic plates, it's beyond the scope of the present study. Finally, optical ghosts typically appear near bright stars or in the crowded galactic plane regions, whereas our candidates are located neither near bright stars nor within the galactic plane. I see, so they're not like you see sometimes the sun will appear as a separate blob in different parts of the photographic frame. Yeah, if you see something like that and the sun's not there, then it can't be that. I get that. Another concern is photographic plate defects. Historically, astronomers have excluded single epoch point sources to avoid false positives. I don't know what that means. An approach that also inadvertently eliminate many genuine short-lived astronomical events. Well, who cares? It means the skeptics are still right. For example, Hamley and Blair 2024 argued that the transients reported in Villarroel et al. 2021, despite their point-like morphology, are likely emulsion artifacts. All right, so the skeptics are already onto this, as they will be onto this draft paper as well. This conclusion was primarily based on the finding that the transient exhibits slightly narrower full width at half maximum values on average compared to normal stars. Right. However, the analysis did not account for the known non-linearity of photographic emulsions, which causes fainter sources to naturally exhibit narrower profiles. Who cares? In addition, the artifact sample in their study was selected using criteria that mirror the Vasco project's transient selection pipeline, which may introduce circular reasoning. Oh, circular argument, the fallacy that skeptics are always accusing us of. Crucially, the study did not consider that sub-second optical flashes are predicted on physical grounds to appear sharper and more circular than stars in long exposure plates, due to the absence of atmospheric seeing, wind shake, and tracking-induced smearing. Oh, yes, again, that's the sort of thing that Avi was talking about with 3i Atlas. These effects are discussed in detail in a dedicated commentary, Villarroel, Solano, and Macy 2025. To date, no study has systematically quantified the fraction of single-plate detections that are authentic transient phenomena versus coincidentally star-like emulsion defects. A summary of excluded astrophysical and observational and instrumental causes is provided, Villarroel et al. 2021. Assuming the observed transients are genuine and not artifacts, we turn to alternative physical explanations beyond the GSO glint hypothesis. Point-like events could be a result of either reflected sunlight or intrinsic emission, in other words, an internal light source. Avi is now claiming that possibly 3i Atlas has an internal light source. As shown in Villarroel et al. 2021, such objects must be located within the solar system. We consider four broad possibilities. The objects are inside the Earth's atmosphere, weather balloons, they are in low Earth orbit, they're not satellites, obviously, or they are in geosynchronous orbit, ditto, or they are located at significantly greater distances. Right, so that would be in cislunar space, I suppose you'd call it. If the transients originated from luminous or reflective atmospheric objects, they should leave visible trails over the 45 to 50 minute pos-1 exposures, given that the telescope tracks stars during imaging. Yeah, so it was moving basically with the way the stars move across the sky. Yeah. Stationary objects would also appear streaked. Yeah, because they'd be floating like balloons while the stars are moving. Yeah. That's true, actually. So if it's an aeroplane, it will leave a streak, and if it's a balloon, it will leave a streak. Yeah. It's only when if it's not leaving any streaks, that it's basically moving with the stars. It's actually up in space. Yeah. Objects very close to the observer would appear significantly out of focus due to the proximity of the focal plane. Yeah, you get that when you're taking a photo yourself. For instance, an object at 50 kilometers altitude would suffer a defocus of several hundred microns on the Palomar 48-inch system, resulting in an extended PSF incompatible with the stellar appearance. Only at altitudes above several hundred kilometers would point-like morphology be achievable. Right, so basically up in space, yeah. This effectively rules out phenomena such as red sprites or rare luminous atmospheric events like the Hessdalen phenomenon. Teodorani 2004. Right. Red sprites are basically lightning bolts that shoot up into the sky, which are much more powerful than the ones that shoot downwards. They're a bit of a scientific mystery. The Hessdalen phenomenon is basically the strange lights that have been seen in Norway. You may be familiar with those, the sort of orbs and things. The only plausible scenario in which multiple objects within Earth's atmosphere could produce point-like transients without visible trails is if they were light emitting and appeared simultaneously for a split second, brief enough to avoid motion blur before vanishing. Yeah, but UFOs. I mean, that's equally interesting, isn't it? Alternatively, they would need to mimic the appearance of stars as seen from Earth. Yeah. Which technically they could do, but then if it walks like a duck and quacks like a duck, it's a duck. If it seems to be moving with the stars or it appears in space, in the focal plane, and indeed moving with the movement of the stars, then it's something out in space, isn't it? You know, it's that kind of thing. If it's something in the Earth's atmosphere mimicking the appearance of stars, well, it would have to have some intelligent reason for doing that. While speculative, such a scenario cannot be ruled out a priori, it would fall under the category of unidentified aerial phenomena. Yeah, exactly. She took the words right out of my mouth. Some asymmetrics are observed in, for example, Candidate 5 might still be marginally consistent with high altitude sources near the upper atmosphere. All plausible scenarios would fit with the observations of UAP, Nuth et al. Yeah, I mean, in those days, aeroplanes didn't fly as high as they do now. LEO, low Earth orbit-based explanations are not impossible, but they're much less likely. PSF glints due to short millisecond flashes can be produced at any orbit altitude by rapidly spinning objects. Nevertheless, objects in low Earth orbit typically leave continuous trails. And explanations involving glints from experimental rockets or missiles at altitudes of 100 to 200 kilometers are probable due to their rapid motion and constrained illumination geometry. Right. There were, even before we put things in space, there were suborbital rockets being tested as early as the 1940s in Nazi Germany. So, I mean, you could say that the V2 missile was an object that did enter space. It flew very, very high and then came down. It was a suborbital ballistic missile. In fact, the first photograph from space was taken in 1946 from an experimental V2 from White Sands, and it was actually so that's over a decade before the first orbital satellite. Yeah. Furthermore, empirical studies based on short exposure CCD surveys, Corbett et al. 2020, Near et al. 2020, have shown that most PSF glints are associated with GSO. Extrapolating these findings to the 45 to 50 minute exposures of POS1 make it unlikely that so many objects would appear as isolated or repeated point-like sources without leaving any streaks in the images. Satellites, of course, if you're taking a long exposure shot of the sky, you will get satellites streaking across it like lines. However, if an object were capable of actively controlling both its motion and its optical signature as perceived from Earth-based observatories, then altitude constraints would no longer apply. Yeah. But then why would it do that? Such a scenario would imply an engineered system of extraordinary sophistication. UFO, yes. Yeah, I mean, of course, that goes without saying, a UFO could do that. It could mimic the stars, as we said earlier. We also considered more distant origins. As discussed in Villarroel et al. 2021, fast-moving solar system objects such as asteroids will produce trails, while slow-moving one should appear in multiple images taken close in time. Objects like tumbling interstellar bodies, like Oumuamua, would also produce visible trails across long exposures. Hence, no known population of solar system or interstellar objects can explain point-like transients that appear only only in one long exposure and are entirely absent shortly before and after. Yeah. While we cannot exhaustively rule out all possible explanations, including those not yet imagined. Oh, here we go again. Yes. But you see, you shouldn't say that, Beatrice, because the skeptics will just imagine one and they'll win using the clown's day off fallacy. I would have left that statement out. Forget the things that are not yet imagined, because the skeptics will just imagine one. They'll say, well, a clown had a day off from the circus and decided to mimic the stars with some balloon he'd invented. They will do that. And then you say, well, what clown? Well, I don't have to explain the clown. It's just which is more likely. You know. The absence of known natural or instrumental causes, combined with the spatial alignment of certain events along a narrow band, calls for further investigation. And maybe the simplest way of testing the mechanism behind these flashes is by performing a test that can reveal whether they originate from solar reflections or not. How would you do that? I think you'd have to launch a rocket into space. But anyway, here we go. Number 8, testing the solar reflection hypothesis. So it says here the Vasco project has identified thousands of short-lived point-like transients in pre-Sputnik photographic plates. And there we have Villarroel et Solano 2022. The multiple transient candidates were found among this general population, with several events sharing similar timescales, morphologies, and apparent magnitudes. It is therefore reasonable to treat the multiple transients as a statistically identifiable subpopulation within this broader distribution. All right, see, they have to go through so much work, these scientists, don't they? Just to like all the intricacies of reductionism. It's incredible. One possible interpretation for transients is that they are caused by sunlight reflecting off objects with flat surfaces in geosynchronous orbits, such as small rotating objects briefly glinting as they pass a favorable viewing geometry. Villarroel et 2022. If this interpretation holds, we would expect a significant deficit of such events within the Earth's shadow, the umbra, where sunlight cannot reach the object to produce a glint. If the transients, on the other hand, are caused by their own emission or are due to plate defects, we would expect no deficit in the number of transients within the shadow. The method of using the Earth's shadow to filter out reflections is further discussed in Villarroel et al. 2025. Yeah, that makes sense, doesn't it? Yeah, again, the skeptics, they will stretch the coincidence argument anywhere they want to. While it's possible to compute the fraction of each photographic plate that lies in Earth's shadow for any given orbital altitude, not all heights are equally meaningful for our analysis. Well, I suppose once you get far enough out, then there is no umbra, because the Earth actually transits the sun and there is no eclipse. Because the Earth, the apparent size of the Earth on the celestial sphere from where you are in space is smaller than that of the sun. At low altitudes, below 10,000 kilometers, is that low? Earth's shadow may cover a large fractions of the plates, making any deficit or surplus hard to interpret. Right. I'm not sure why that would follow. It would either be that you'd be able to tell, wouldn't you, by taking multiple plates? Anyway, while plate defects do not respond to the position of the Earth's shadow, plate defects do not respond. The diagnostic power of this test depends on the assumption that the shadow is randomly placed with respect to plate geometry and artifact distribution. So again, this is that is statistical, because you're going to get the defects on the Earth's shadow too. So you got to measure the amount of defects you're getting from the Earth's shadow the umbra photos compared to those you're getting when there is sunlight. When the shadow covers a large proportion of the plate, that is more than 50%, this assumption breaks down. And even a random distribution of artifacts will naturally yield an overdensity in the shadow regions. In such cases, the test becomes less sensitive to systematic avoidance, making small shadow coverages, e.g. greater than, smaller than 5 to 10% more reliable. Yeah. So the test becomes less sensitive. I don't quite get that. Sorry. Moreover, reflective objects in low orbits tend to move rapidly and often appear as streaks rather than point spread functions, like transients. Oh yeah, we've been through that. Since our sample only includes PSF-like detections, it's physically unlikely that many of them originate from low Earth orbits. And I suppose again, like I've said before, what could be causing them in the pre-satellite era, where glints would need to be extremely short-lived in the order of milliseconds, so you don't get this streak. Yeah. For these reasons, we focus our main analysis on altitudes where less than 5% of the field is typically shadowed, regions where the shadow behaves approximately randomly, and where reflective glints, if present, would be both detectable and physically plausible. We use the transient candidates from Solano et al., but with the additional requirement that they have no counterparts within 5 arc seconds in either Gaia or Pan stars. These are telescopes. Furthermore, we restrict our analysis to objects in the northern hemisphere, that is greater than 0 degrees. I think it's declination 0 degrees. Does that mean the equator? I assume that means the equator on the celestial sphere. This yields a sample of 106,339 transients, for which we use for our study. An important note about the sample is that, contrary to the other transient candidates discussed throughout this this sample has not been visually inspected. Right. So again, they're just using the methods, the flowchart method that they've been describing. As such, it is expected to contain a substantial number of false positives, including clustered artifacts such as edge fingerprints or other plate defects that contaminate our sample. Yeah, a little blob of vignette from your vegan salad. Yeah. In addition, the spatial distribution of the sample is not isotropic due to inhomogeneous sky coverage. What do those words mean? Homogeneous means all the same. So if you put in like coffee and milk into a cup, it may first form little blobs, then you stir it and it becomes homogeneous. Isotropic, I don't get. Inhomogeneous, I suppose, means the opposite. Sky coverage in the original POS1 survey. Some regions of the sky are more densely sampled than others, leading to a variation in the overall detection density. I see. That's the inhomogeneous bit. Yeah. However, these effects do not bias the result of our shadow analysis. The reason is that we are comparing a small, well-defined subset of this population, those that fall within the Earth's shadow cone at the time of observation, with the rest of the same population. Since the selection efforts and potential false positive affect both the shadowed and unshadowed regions similarly, any large and statistically significant difference in detection rates between these regions must reflect an intrinsic property of the detections themselves, not an observational bias. Yes, fair enough. Or to express it simply, plate defects do not know where the Earth's shadow is. Thank you. Yes, that's in italics, just for we laymen, and have no reason to avoid that region more than any other. It's amazing what you can say in one sentence, but this is aimed at scientists. This is not aimed at the general public, which is why I say, what the hell does that mean half the time? The fraction of transients expected within the umbra depends on the angular radius of the Earth's shadow at different altitudes. Yes, of course, because like any shadow, I see, when you're right close to the Earth, it basically fills half the sky. When you're on the surface, it fills the whole sky, like when you're on nighttime. Yet, when you move a little bit away, the Earth becomes smaller, so you're still in the shadow, but the actual range of if you move to one side a little bit, you'll be out of the shadow. And eventually you get to the point where you're outside the cone of shadow, which, as I said earlier, is when the Earth no longer eclipses the sun, and you can actually see the sun will actually appear around the entire circumference of the Earth in a sort of annular way. And eventually, if you go far enough away, the Earth will just be a little dot. It'll be transiting the sun. We use the software library Earth Shadow, published by Guy Neer, to estimate the size of the Earth's shadow at 40,000 kilometers, 8.69 degrees, and at 80,000 kilometers, 4.57 degrees. Right, so that's twice the distance, roughly half the shadow width. That's fair enough, yeah. The code determines whether any given point at a specified altitude, the cone at geographical position lies inside the Earth's shadow. That makes sense. Yeah, you need to know. Well, you need to know how high this object was, wouldn't you? Based on the solar angle and the geometric configuration of the Sun, Earth, and the object, we apply it to each transient using their J2000 coordinates and Julian dates. We compare the expected and observed rates for two different altitudes capable of producing PSF-like transients, namely 42,164 kilometers and 80,000 kilometers. We calculate the expectations based on how large fraction of the northern hemisphere is covered by the shadow and compare with observed fractions. We calculate the area in two different ways, both based on spherical geometry. 2 pi and something like that. Whenever you get to spheres and circles, you always have pi, don't you? As well as planar sky coverage as an approximation. And there's a table coming up. To verify independently the number of transients located within the Earth's shadow, we implemented a custom code using ChatGPT assisted script. They're not going to take over anytime soon. Fear not, our robot overlords. That follows a similar principles to Earth's shadow. After validating its performance on a subset of candidates from Villarroel et al. 2025, we applied it to the full sample. The result counts 374 transients at 42,164 kilometers and 57 at 80,000 kilometers are in good agreement with the results obtained using Earth shadow, supporting the robustness of our shadow deficit measurement. Right. So basically, they were saying that they theorized there'd be fewer of them in the shadow than there are. To estimate the statistical significance of the difference in transient detection rates within Earth's umbra at different altitudes, we compute Poisson, or is it Poisson? That's French for fish, isn't it? Poisson uncertainties for the observed and expected fractions. That's something to do with statistics. I know because the skeptics mentioned this at one point. At 42,164 altitude, we expected N to equal 1,223 transients in shadow out of 106,339 total, corresponding to an expected fraction of blah-de-blah. However, we observed only 349 transients in shadow, yielding something or other. The difference between these fractions is highly significant, with a significance level of, again, there's a statistic computed by combining the Poisson uncertainties, and there's your table there. Anyone who knows anything about that can read this. I'm not going to try and interpret this. And there's your little weird little formula there. At 80,000 kilometer altitude, we expected N to equal 339 transients in shadow out of the total I mentioned before, corresponding to a fraction of, there you go. However, we find only 79 in shadow, yielding blah-de-blah-de-blah. The difference in these observed fractions is highly significant, with a significance level of, again, a statistic, computed by combining the Poisson uncertainties in the quadrature, whatever that means. I don't know what a quadrature is, something to do with number 4. Quad, you know. This result further strengthens the conclusion that sunlight is necessary for producing the transient events. In other words, reflection. Like they do with satellites that we see, like I saw in South Wales when I was with Rhiannon a couple of years ago. The strong deficit of transients within the Earth's umbra suggests that the majority of these events depend on sunlight illumination, consistent with the glint hypothesis. This strongly defies the plate defect hypothesis and many of the alternative hypotheses presented in section 7. Yeah. Plate defect again, and also the fact they have an internal light source. We performed an additional test to estimate the actual fraction of the survey sky that was covered by Earth's shadow during the actual POS1 observations and compare it to the actual observed fraction of transients falling within the shadow. The transient sample is based on 635 unique photographic plates, each with a designated central coordination in J2000 and a corresponding observation time. Each plate spans 6 by 6 degrees of the sky. Right? So it's a lot bigger than the others. As listed by etc. We estimated 180 random points per plate out of a total of 114,300 points. For each simulated point, we tested whether it would fall within Earth's shadow at a geosynchronous altitude 42164 during a 50-minute exposure from the recorded observation. Out of 114,300 simulated points, 180 points per plate, 610 were found to lie within Earth's shadow, implying that approximately 0.53% of the survey area should be shadowed at geosynchronous orbit. However, in our actual transient data set, only 349 out of that number, 107,879 of the events occur within the shadow, corresponding to, again, summing deficit significantly at the statistic level. We repeated the same procedure at a high altitude of 80,000 kilometers. In this case, the actual shadow coverage drops to 109 out of 114,300, 0.1%, while the observed fraction of transients, 76 in 107,875, within the shadow is only 0.07%. Right. Again, how do they calculate the altitude of these objects unless they have like a stereo photograph from 2 points where you can triangulate them? Maybe that's implied and assumed within this paper. I don't know. This is again significance. The simulated points within each plate are used solely to estimate the expected geometric coverage of the Earth's shadow during the exposure time, and are not meant to represent the spatial distribution of actual transients. This also suggests that a larger fraction of objects may be located near GSO than at 80,000 kilometers. Is the 42,000 kilometers geosynchronous? I know it's a certain level, isn't it? It's geosynchronous. 80,000 is higher. Although the limited number of events at 80,000 kilometers makes the comparison statistically uncertain. We perform an additional conservative tests on the transient, this time assuming a total exposure time of 50 minutes, while our main shadow test assumes that the transient event occurs at a single moment, which is reasonable given their short duration. We now test whether the Earth's shadow passes through the transient's position at any time during the 50-minute window. This increases the chance that the transient would fall within the shadow. We find that 387, 0.3587, are in the Earth's shadow at 42,168 kilometers and at 80, 0.72 at 80,000 kilometers. Even under this generous upper limit assumption, where a transient is considered shadowed if the Earth's shadow passes through its position at any during the 50-minute exposure, the deficit remains strong. This result provides robust evidence that the Vasco transients systematically avoid Earth's shadow, consistent with a population of reflective objects that are only visible when sunlit. Yeah, they're probably there, but you just don't see them because they're not reflecting. The normalization technique presented here is grounded in a direct simulation of shadow coverage based on actual photographic plates used in the survey. Each plate's position in observation were used to simulate uniformly distributed test points across the plate area, allowing us to estimate the expected fraction of the survey sky that falls within Earth's shadow. This approach minimizes assumptions and avoids potential systematic biases that may arise from analytical solid angle approximations. To avoid introducing spatial selection bias, we include all observed transients in the analysis, including those clustered near the edges of the plates, since plate defects do not know where the Earth's shadow. A quick check, nevertheless. We also test by masking edge transients less than 2% from the plate center, greater than 2% from the plate center, to remove all artifacts close to the plate edge. Removing the edge of the plate in this analysis yields a similar 30% deficit in Earth's shadow, though with borderline significance. As a note, at low altitudes where the shadow covers a large fraction of the plate, it's also possible to observe a significant overdensity of transients in the shadowed region. This is a natural consequence of the geometric coverage. When most of the field lies in shadow, any transient, regardless of origin, is statistically more likely to fall there. Such over-densities are therefore not physically meaningful and cannot be used to infer the nature or altitude of the objects. We therefore recommend restricting the analysis to altitudes where the Earth's shadow covers no more than 5% of the plate area. In other words, like, as I said, nighttime on the Earth's surface, the Earth's shadow is everywhere, isn't it? Yeah. In order to preserve the assumption that its placement is effectively random with respect to plate geometry and defect distribution. As important implication of this analysis is that the total number of glinting objects near geosynchronous orbits may be significantly underestimated if one considers the aligned transient candidates, since they represent only a minor subset, albeit visually vetted, of the full transient population. Our results suggest that a much larger population of objects capable of producing sunlight reflections exists, as inferred from the full Vasco transient example. Yeah, they're up there, you can't see them. This systematic deficit of transients in the Earth's shadow, especially at altitudes where sunlight reflections dominate, supports the interpretation that a significant fractionally, roughly 1/3 of all Vasco transients are caused by highly reflective objects in geosynchronous orbit. However, in order to determine the absolute number of such objects, we would need to quantify the true fraction of false positives in the example, such as artifacts and plate defects, a major undertaking that will be addressed in a forthcoming study. Right. The GSO hypothesis, that's geosynchronous orbit. In this section, we discuss the conditions under which reflections from objects in geosynchronous orbit could produce the observed glints. An important question of what types of objects, shapes, and reflective geometries are capable of creating the transient signatures observed in the POS1 plates. Right, now this is where we come onto the structure, which I talked about earlier. A rapidly spinning object may produce multiple glints during a 50-minute exposure, whereas a more slowly rotating object might generate only one or two. If we assume a fast spin rate and interpret this observed stripe length as corresponding to the path traversed by the object during the exposure, we can estimate a projected velocity of approximately 0.5 arc seconds per second. This is significantly slow. That's the apparent velocity. It's not the actual speed of the object. This is significantly slower than the nominal angular velocity of the object at GSO, 15 arc seconds per second. Under these circumstances, we might expect additional transients to be visible along the same narrow band, particularly if the image were extended. Conversely, if the object spins slowly and has only a few small, highly reflective surfaces distributed across a predominantly non-reflective structure, glints may occur only briefly during the exposure and only at specific orientations. Again, this brings us back to Oumuamua, doesn't it? To explore this further, we used the open source graphic engine Blender to simulate how Blender, I bet that's what they call the Friday night gathering at QED, the conference, remember? Oh, that's finishing, by the way. I'll say more later. I covered it on Japan Voice. How various 3D shapes could produce glinting patterns similar to those observed. We modeled 5 distinct geometries. This is interesting. A sphere, a multifaceted polyhedron, a cone, a double pyramid, and a structure with 2 reflective panels. Each shape is composed primarily of a non-reflective material with limited flat surfaces capable of producing strong specular reflections when oriented precisely between the observer and the sun. In addition to rotation, we allow for precession in some models, which modulates the visibility and timing of glints. Precession, what does that mean? The 5 test geometries are shown in figure 6. As expected, a purely spherical object does not generate short, distinct glints. Yeah, like Atlas at the moment is not actually showing any rotation. It's interesting. Or at least it wasn't when I last looked. Flat mirror-like surfaces are required. In the cone model, we assume that the top and bottom surfaces are reflective, yielding double glints per rotation cycle. Adding precession further restricts glint visibility, producing only a few observable flashes per exposure. The double pyramid model illustrates another plausible cause, a reflective structure that becomes partly degraded over time, leaving only small reflective regions. With rotation and precession, such object may produce intermittent glints, consistent with what we observe in the data. Right. This is interesting. These are possibly the shapes of the UFOs or whatever they are. about, you see, the bright bits are where they reflect the sunlight. The cone in this case has a flat top, not a point. And that's what they look like at some different ways, different angles that you look at them at. I'm trying to think of a word and I can't think of it. See, this is like, it's like a multiple dodecahedron thing. There's the sphere with like different levels of reflection. Aspects, I think, is the word I'm looking for. Here's that's the double pyramid there. And is that a tetrahedron? Here's an irregular shaped object. And this is just explaining what a hexagon a piece of debris would be, this irregular bit. Yeah. But where would the debris come from in 1950? Overall, we find that each of the 5 test shapes, under specific assumptions regarding spin, precession, and reflective surface coverage, can, in principle, reproduce a glinting pattern comparable with the transients observed in POS1 images. She so understates it. She's literally discussing non-natural objects, and in space before we went up there. The geomagnetic models presented in this section are intended to demonstrate the plausibility of producing aligned glint patterns from tumbling or precessing objects in high altitude orbits. We emphasize that these models are illustrative, as Kelly Chase calls it, rather than predictive, and no attempt is made to fit the specific time separations or angular offsets of the individual candidates. So that's not what they actually look like. That's what they might look like, based on the reflective data. While no clear periodicity has been identified in the current POS1 data, it's well known from modern short exposure surveys that some Earth-orbiting objects, including those in geosynchronous orbit, can produce isolated PSF-like glints without clear repetition patterns, near et al. 2020. And that, I presume, refers to known artificial satellites. This lack of periodicity may result from slow rotation, irregular shapes, or specific phase angle constraints that produce only a few observable flashes per orbital cycle. Additionally, the observed sky distribution of aligned transients does not always follow a simple great circle geometry, which could reflect the possibility of complex trajectories, altitude drift, or even the presence of multiple independent objects. Powered objects could even change their altitude or trajectories. Well, presumably, how did they get there if they weren't powered? Presumably they can move, yeah. We acknowledge these uncertainties and note that more detailed modeling would be required to establish stronger constraints on orbital parameters or glint periodicity. And so we have identified 83 R-point alignments within the northern hemisphere alone. Assuming isotropy, we can estimate 170 R-point alignments as the lower limit for the whole sky. That's projecting what else you might see in where the telescope couldn't see. It's just an estimate. These are assuming that these objects don't just appear where the Palomar Observatory can see it. These alignments have been sampled during a period of 16 years when the POS1 survey was undertaken between 1949 and 1958. Minkowski and Abel, 1963. POS1 sampled the entire northern hemisphere and southern up to declinations greater than minus 45. That's how far I can see to the horizon, basically. That's how far the maximum south horizon is. During this period, 936 red fields were observed with 50-minute exposures, each giving a total of 780 hours of exposure time. Each exposure covers 6 by 6 square degrees, which means roughly 80% of the sky was covered. If we take the 170 cases to estimate the rough detection rate, we can simply divide 170 by 780 hours and sky coverage, which gives us 0.27 hours sky. This is higher than the 0.07 events hour sky estimated in Villarroel et al. 2021. It's also significantly lower than the glint rate of the whatever that is, McDowell, etc. 2020, and Corbett, etc. 2020. Not the Corbett report, I'm sure. Arising from human space debris and satellites observed from the equator, which is why it would be nearly impossible to detect this background population of objects unless it is specifically looked for. And of course, in those days, there were no satellites and things. Modern short exposure surveys, such as the ZTF, operate under vastly different conditions using CCD's automated pipelines and millisecond level time resolution, whereas the POS1 transients were recorded on photographic plates with long integration times and are subject to different detection biases with false positive rates. That's talking about the difference in technology. A rigorous comparison would require modeling of completeness, instrument sensitivity, and even classification criteria, which is beyond the scope of this study. We can also calculate the actual number density of objects if we assume that the population of objects has a uniform number per square surface unit and the number of objects is detectable at any given time by, and there's some statistics there. I won't go into this. I won't go into because that's just details. These estimates provide a guide to the number of background objects that may exist inside the surveyed volume. However, not every object will produce several glints. The shape and reflectivity of an object will determine the likelihood for one or more glints. This uncertainty also leads to an underestimation of the number density of objects, which could actually be even one order of magnitude higher. The surface density constraint quoted here is a first order estimate based on our event detection rate and assumed sky coverage. These estimates do not include a full treatment of incompleteness, observational bias, and formal statistical confidence levels, and therefore should be interpreted as an indicative upper bound rather than a rigorous limit. Moreover, the true fraction of false positives in a larger sample from Solano et al. 2022 due to plate defects or other instrumental artifacts remains unknown. Well, they've done what they can to try and sort that out, I think. While the overall statistical test in Section 8 is robust to this uncertainty, as I just said, the absolute number density inferred here should be interpreted with caution until a full validation of the sample has been performed. And here we have 10. Discussion. Are there signatures of artificial objects in Earth's orbit pre-Sputnik images? This is the central question explored in the present study. We adopt a straightforward strategy, searching for multiple transients aligned along a narrow band within long exposure photographic plates from a period prior to known artificial satellite activity. This approach follows the principle of seeking non-terrestrial artifacts via distinctive, low probability observational signatures or smoking gun indicators. That's a good. I'm glad they're getting more colloquial now. Villarroel et al. 2021. Using the published catalogue of Vasco transients in the Northern Hemisphere, Solano et al. 2022, we identify 83 initial candidate R points alignments, along with a larger number of double and triple transient groupings. Triplets are of particular interest, as they are consistent with reflections from flat rotating surfaces. Dial et al. 2009. Flat rotating surfaces. Yeah. One such example was previously reported in Solano et al. 2023. We manually inspect all 22 candidate alignments containing 4 or more transients, noting that some reduce to 3 after closer analysis, and highlight that the 5 most statistically significant cases in Section 6, although the uncertainties do not allow us to compute a total occurrence probability for such alignments across the entire survey, we do not estimate the chance probability of each event within a single field. Those were the pictures I showed you. These estimates, dependent on assumptions about point spread function widths, yield significance levels ranging from 2.5 whatever to 4 for the most promising cases. Notably, 3 candidates with 4 or more aligned points emerge as especially strong, although 2 of them show minor morphological irregularities. These are unrelated to FWHM differences which are addressed separately in the literature. Villano, Solano, and Marcy, 2025. Among the remaining 3-point alignments, 61 in total, we may also merit follow-up if confirmed as genuine transients. Traditionally, this would require microscopic examination of the original plates. However, our discovery of a statistically significant, more than 3, temporal correlation between Vasco transients and independent historical reports of unidentified aerial phenomena, Bruhl and Villarroel, 2025, offers additional support for the authenticity of the transients. Plate defects or scanning artifacts are expected to occur randomly in time. The fact that these transient alignments appear preferentially within a day of reported UAP events strongly disfavors instrumental or spurious origins. That's, again, referring to the July 1952 Washington flap. In this light, the correlation of itself provides indirect but meaningful validation of the transient's reality, thus reducing the necessity of microscopic inspection as the only path to confirmation. But most importantly, Section 8 presents a critical test of the glint interpretation. We find a strong deficit of transient detections at the 22 sigma statistical significance level within the Earth's umbral shadow. That's talking about the fact that they don't reflect. This is consistent with the idea that sunlight is required to produce these observed flashes. If these events are sunlight reflections of orbiting objects, they should vanish in the shadow cone of the Earth, exactly what we observe. This lends substantial reports to the interpretation that the transients are real astrophysical or near-Earth events and not plate defects. The disappearance of the population in Earth's shadow would not be expected for emulsion flaws or chemical irregularities. Of particular interest is candidate 5, which occurred on the 27th of July 1952, the second weekend of the widely documented Washington, D.C. UFO flap. This wave of sightings involved numerous radar detections and pilot observations over 2 consecutive weekends, again 18th and 19th and 26th and 27th of July. Coincidentally, candidate 1 also occurred within 1 day of the peak of the 1954 UFO wave. The triple transient reported in Solano et al. 2023 falls on the first weekend of the Washington event. Importantly, these candidates were analyzed before the authors became aware of their proximity to UAP reports, helping to minimize cognitive bias. All right. Well, I mean, I don't know about that, because surely someone among that group of people knew about the Washington invasion, surely. Not that that means they didn't do the science properly, but it's saying that nobody knew. They were not aware. I doubt that. Additionally, a correlation has been found between Vasco transients and historical nuclear test dates. Breuer and Villarroel 2025. That's interesting, isn't it? Echoing past statistical studies linking nuclear activity to increased UAP reports. Nuth et al. While causality remains undetermined, the conversion of these independent correlations suggests that the Vasco transients are not random artifacts, but potentially linked to physical phenomena worthy of study and investigation. Yeah. I've got time to show you my UFO photo. I've done an entire video about that, but maybe I should try and show you my UFO photo. Let's have a look. I did a couple of videos about it. Let's see if it actually appears. I'm only going to use the search function. Here we go, long lost UFO photo. Here we go. I have found it. And here it is. I know you can't see it very well, but you can watch these videos. This is the actual full. Do you see there? Do you see the little object there? It's not definitive, but I took that. There's a nuclear base down there, Faslane submarine base for the Trident system. There's the Coolport RNAD up there. I saw all these places when I was there. See, and there you go. So you can always look those videos up if you want to. Okay, so let's carry on. Using the theoretical framework outlined earlier, we simulate glinting patterns from plausible object shapes in geosynchronous orbit. These include multifaceted and partially reflected objects with slow spins and precessing axes. We derive a detection rate of 0.27 events per hour sky for aligned transients and 120 events hour sky for all transients associated with specular reflections. The inferred surface density of detectable objects is 3.2 times 10 to the power minus 6, though this estimate is subject to uncertainty both from unknown shape and reflectivity factors, which may cause underestimation, and from the unknown fraction of false positives in the sample, which may cause overestimation. Yeah, you've got to bracket it a bit, but still, as long as you take into account the errors, the precision of the methodology, it shouldn't be a problem. Although the GSO hypothesis is consistent with the data, no clear evidence for periodic or quasi-periodic glinting has yet been identified. Again, if you know the altitude of the object. Objects spinning slowly or possessing complex reflected geometries may produce only a few flashes, complicating efforts to establish repeating signature. I should point out, actually, surely you can actually calculate the altitude of an object through triangulation, parallax, with two telescopes separated by a long distance. Moreover, it remains possible that some events extend beyond the field of the single plate. An object moving at 10 arc seconds per section could traverse up to 10 degrees during a 50-minute exposure, suggesting the possibility of longer alignment change than those captured here. Conversely, if all transients were confirmed as false positives, yeah, the skeptics will do that. E.g., due to a rare but star-like photographic plate artifact, our search still constitutes a meaningful upper limit on the density of non-terrestrial artifacts, NTAs, in the near-Earth environment. In this scenario, we derive a rough surface density constraint of less than 10 to the power of -6 objects for high-altitude orbits in the Earth's vicinity, thousands to hundreds of thousands of kilometers, even if this limit must be carefully approached due to the lack of modeling for bias and incompleteness. Thus, regardless of interpretation, our findings provide new constraints on possible techno-signatures near the Earth. Oh, they said it, techno-signatures. Future work should consider searching for dashed line alignments over large plate regions and investigating subtle elongation effects in high-resolution digitizations. That's be like when you get, like, as I said earlier, you get like a glint, 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 and indeed there's pictures of 3i Atlas like that. Such elongations could indicate motion across the sky or large object size, especially if consistent with the alignment direction. In other words, it's long, like Oumuamua, but bigger. In summary, we have presented a small but compelling set of aligned transient candidates for a pre-satellite era sky survey. While the ultimate explanation remains uncertain, the convergence of spatial alignment, statistical significance, and temporal correlation with independent aerial anomaly reports supports the view that these events are likely real and may represent a class of astronomical phenomena not yet understood. Alternative explanations are discussed in section 7. We've been through that. Conclusions. It's just really so understated. The implications of what's said here is incredible. This paper presents a first systematic search of multiple simultaneously appearing and vanishing optical point sources on long exposure photographic plates that also exhibit spatial alignment. We focus on the red POS1 plates and present 5 top candidate events with 3 or more transients aligned along a narrow band. The most statistically significant case, candidate 5, coincides in time for the well-documented Washington, D.C. 1952 UFO flap, one of the most prominent mass sightings of unidentified aerial phenomena in recorded history. A separate study, Bruhl and Villarroel 2025, confirms statistically significant greater than 3 temporal correlation between the Vasco transients and independent historical UAP reports. The origin of the transients remains unknown. Of course, you in the UFO or UAP. One plausible explanation is they're caused by brief light emissions from artificial objects in orbit, or by objects with anomalous movements in the Earth's atmosphere, but emissions so brief that they appear as point sources rather than streaks. But what about the shadow? I thought you said they were in the shadow, though, and there were none in the shadow, or less in the shadow. Okay. Despite the telescopes tracking the stars. Alternatively, they could arise from solar reflections off flat, highly reflective surfaces at geosynchronous altitudes. The latter interpretation is further supported by our shadow test, again, in section 8, which reveals a significant deficit of such events within the Earth's umbra, consistent with a solar reflection origin and difficult to reconcile with many explanations, including photographic plate defects. Our results motivate continued investigation of historical sky surveys and the application of similar alignment-based detection methods to modern deep sky imaging. Whether or not these events ultimately point to the existence of NTAs, the identification of statistically improbable spatially aligned transients in the pre-satellite data represents a novel observational anomaly deserving further scientific attention. You say that again. Future work may help clarify whether these transients constitute a new class of astronomical phenomena or represent the first hints of artificial activity near our planet. The latter, I would say. Yeah, but you see, they understate it, but they're basically saying that, you know, you need to look into this and take it seriously. And there's just acknowledgements here. And she mentions Dennis Ospier, who actually worked on the if you believe it, if you know, he worked on the Baltic Sea anomaly, and I'll just touch on that in a minute. And also Dave Altman, who's for teaching about the Washington UFO flat. Dave Altman, as you know, I actually have met him. I've actually not met him, but I've spoken to him and interviewed him a couple of times. So yeah, I know that he's been working with Beatrice, and there's various other people here. And these are various acknowledgements here. There's a lot went into this, as you see here. And there's references here. And there's some more pictures. This is an appendix here with the various candidates. This time it's more like before it was like a photographic negative. Now it's like with spaces black, as you can see here. Candidate 2. Look at this. So that's the supposed alignment there. There we are. Amazing, eh? There we are, and that's it. Okay, so was that right? Was that dive deep enough for you? I'm sure some of you are wondering why I spent so long just going through that paper. I wanted to just go through that, so even if I didn't understand every bit of it, I knew kind of what was going on. I understood kind of the basics. At least I even if I didn't understand it, I'd actually read the original document and shared it with you, so you don't have to read it now because you just heard me reading it out. Because I got a feeling that what you've just heard and what I just read is going to be significant in future productions on Hapanwo TV. But there's more. There's much more going on now. This is where it gets a bit touchy because I mean I've said many times in my SETI talks that cover-ups cannot happen in astronomy for reasons I explained earlier. The world's only truly democratic science. All the data's above our heads. So many telescopes, so many astronomers, as I explained earlier, and I explained in my SETI talks. How can you have a cover-up in that? But it seems there was an attempt. Now, pardon me. Beatrice herself brought this up in her first interview with Ross Coulthard. She said that there was some suspicious activity around the time that this sky survey was being done, like the POS-1 and POS-2 sky surveys. And it referred to an individual, quite a rather contentious individual in the world of ufology, Dr. Donald Menzel. Now, many of you have heard that name, which is rather strange because he is listed as one of the Majestic 12. Yeah, at the same time, was it him? I think it was him. Was it something? It was. I think it was him. But he also, strangely enough, I know there was a big time UFO skeptic mentioned as one of the Majestic 12. Was it Menzel, someone else? And people thought it a bit weird that he was in Majestic. But Donald Menzel was a massive UFO skeptic. He was like the Philip Klass of the previous generation. And what happened was he actually started collecting some of these photographic plates because he was director of the Harvard Observatory from the late 1940s. And Beatrice believes that Menzel had a specific role in the destruction of a significant proportion of Harvard Observatory's photographic plate collection, and also try to put a kibosh on new data collection. And luckily, I mean, it didn't affect Palomar, it appears, because all the photographic plates are intact. But in Harvard, they call this the Menzel Gap. Now, Avi Loeb is in Harvard. In fact, he's head of astronomy and astrophysics at Harvard. The Menzel Gap is quite significant. It's a significant number of years. In fact, it's 15 years, 1953 and 1968. And what happened was that Menzel issued a directive saying a significant number of Harvard's astronomical plates were to be destroyed. And it's possible that these plates contained the kind of historical sky observations which showed the same transients, the same objects that she detected on the Palomar data. Roughly in the same time period as well, from the early 1950s. In her case, it was like from the early 1950s, but in his case, it went much further into the future, towards the late 60s. And most of these years predated as always human spacecraft. And this is the Menzel gap. It meant that essentially data was both destroyed, previous data was both destroyed, and none was collected. And this is very suspicious, considering this guy was the biggest UFO debunker before Philip Klass. I mean, he was like Mick West, although of his time. Although, as legend have it, he wasn't as amiable as Mick West. He was a bit of a dickhead, quite frankly, from what I hear. As people said that about Philip Klass. He has been well known. He was like he was the pop UFO debunker of his time. And he had links to the US intelligence community. He was known to be in the CIA. And as I said, he's in MJ12. He's been accused like that. People like the late great Stanton Friedman, who I'm sure you all miss as much as I do. I wish he was here today to talk about this. He said that Menzel had been involved in the suppression of other pieces of evidence related to UFOs, the Roswell incidents and things like that. And if you look this up on Wikipedia, it just says, well, it was just a budget cutting thing. They were running out of storage space. So rather than hiring new warehouses to keep these placed, this was in the days before, compact digital storage disks and things like that. Rather than just buy or rent new warehouse space, they decided just to throw it out with the rubbish. We don't need it anymore. Like I would do in this, which I'm going to have to do shortly in my bedroom if this pile of books gets any higher. I'm afraid some of them are going to have to go. It seems a little bit convenient. I mean, that's possibly a plausible explanation on one level, but it seems a bit convenient considering Mendel's beliefs, considering the fact that Menzel was such a massive debunker. That's a bit concerning, isn't it? And that's why I agree with Beatrice. We should be suspicious. She hasn't gone as far as accusing him directly. He's been dead for years anyway. But we should be very, very suspicious about that, I think. Now, Beatrice has been involved with Dennis Osperia, who is the. I'm sure you're all familiar with the Baltic Sea anomaly as well. I've also covered that before. But she collaborated with Dennis Osperia. He was one of the leaders of the Ocean X team that discovered the Baltic anomaly. It's going back to 2011, a long time now. This was during the old Leeds exopolitics era. But she was actually really interested in this, even though she's an astronomer. This is a more kind of archaeological underwater Graham Hancock type thing. She was interested in that, and she began to investigate this structure. Now, it has been narrowed down where it was located. I know that the Ocean X team didn't want people to know where it was. They kind of had to admit it because they couldn't actually keep the ship there in winter because of sea ice. Now, the Baltic Sea does not freeze over in winter, apart from the Gulf of Bothnia. This is the part of the Baltic in the north which lies between Sweden and Finland. That actually does freeze over in winter regularly, and in fact, some years you can even walk from Sweden to Finland across it. But don't try it. Don't try it, ladies and gentlemen. Disclaimer: please don't try it. You'll probably end up falling through a gap in the ice and drowning. But but this, of course, as you know, was discovered. It's been described as being like the Millennium Falcon. This strange object, this strange kind of like 60-foot wide, disc-shaped, irregular disc, like the Millennium Falcon. And it's a bit inexplicable how it actually got there. But she actually was very interested in it, and couple of months ago, she actually went on a trip on board the ship to visit the location, and she actually posted all about all this on her Twitter account. And she's done interviews where she she talks about it. She understands that there's like a cover up of these kinds of things. It's actually, let me just have a minute. It's 60 meters. That's bigger, actually. It's 180 feet across. I was using feet there. I don't like using meters. I am a Brexiteer. But she's interested in this sort of thing. And anyway, what I'll do is let's have a look at her. She talks about various things here. I mean, I mentioned before the Baltic Sea thing. Nothing recently. No. But let's just look at it. She says, new preprint by Steve Brule will investigate the pre-Sputnik transients statistically that correlate with atomic bomb tests. You see UFOs, star. This is not the study you're all wondering about. Okay. This is basically one of those associate papers that we were talking about in that particular one that I read through. So that's very interesting indeed as well. That's I think it's interesting that it's good that she's interested in that, but it's also very, very suspicious what she says about Donald Menzel. And there's also some kind of like revelation about her attitude, about how she knows or accepts certain things. That is the presence of a cover-up. If you want to read her article, it's here. Like I said, I'll remind you, La Tribuna del País Vasco. That just means the Tribune of the Basque Nation. That's not like nothing to do with Vasco, her project. And you can translate that if you want. But I think this relates directly to the work of Avi Loeb. Now, I'm not going to go into this in detail now. I might actually do another video about this. I've certainly covered this in a couple of her Panwo voice articles. And indeed, here is my Interstellar Objects portal, if you want to know more. There's a couple of new articles on here, and of course the videos. And there's also Third Rail Radio Program 215 you might be interested in. But here's Avi's blog, and there's all kinds of new articles in here I won't go through. But this is the new one that's just been, I haven't actually seen this one yet. Today's Q&A about 3i Atlas. Okay. And there's a lot of people have been asking questions here, which will be interesting to read. Yeah, and then of course there's also this one here. 3i Atlas has no visible tail or spectral fingerprints of gas around it. That was from yesterday. So far it's not looking like a comet. Now, and we'll go back here. And again, he says this thing here, the duck test of 3i Atlas, does it look like a duck, quack like a duck, etc.? There we are. I've been commenting on these articles, actually. If you're interested in reading my comments, you can read them. Where's the responses? There we go. Where's my seal responses? I think I put a comment on here. Did I? I've put a comment on some of them anyway. You can find out if you want to read them. I've been putting comments on there. But I mean, so far, at the current point in time, let's just have a look at where exactly. I'm just going to check and see exactly where 3i Atlas is. Actually, I wasn't going to do this, but maybe a good idea to do this. Let's see exactly where 3i Atlas is. Let's have a look. Give me a moment. I'll just pull up the actual. Let's just have a look here. No, it's not that one. Here we are. We'll just have a quick look and see. This is the details on the sky live. If it will load, but we can see where it is there. Okay, so let's go that way. It's easier to look at it from this section. You can see the retrograde nature of it applying. It's still roughly between Mars. As you see, Mars is going to go that way, and this is going to come closer. It's going to come very close to Mars. Then Venus is going to go around here, and it's going to come within like 0.8 AU of Venus, and eventually a flyby of Jupiter. If it stays on course, it's still listed as a comet, so it has a little tail there pointing away from the sun. But as I've said, many, many times before, we don't know this is a comet. And at the moment, it's still not showing any signs of cometary activity, according to Professor Loeb. Now, this could change. Obviously, once it gets closer to the sun, and we should be able to observe it because we have at one of the Lagrange points. This is like a gravitational. This is like a gravitational neutral zone, which is where James Webb Space Telescope is currently based. So it should give us a slightly better view of the comet the object near perihelion than you see from the Earth. And indeed, you know that they may be thinking of repurposing the Mars Express or the Tianwen orbiter to actually observe the object 3i Atlas as it goes behind the sun where we can't see it from the Earth. At some point, if it's a comet, it's going to be very obvious because it's going to get close enough to the sun. There will be the visible tail. That hasn't happened yet. Will it happen? We don't know. But I've got a feeling I will have to come back to this subject as well at some point. In the meantime, what's coming up? Well, I might be doing an Alt-Tech exclusive this weekend. Because of that, I can't really tell you what it is because it is a little bit dodgy. I'm not sure yet. But if not, even if I don't do that, I'll think of something else to make a video about. Anyway, I do hope you enjoyed this one. Thanks for everyone who stuck with me during the reading of that paper. Despite the fact it was very long and a bit drawn out, and some of you might have found it a bit boring, I thought it was necessary to do that. It really, really was. So this is exciting because we've got both Dr. Beatriz Villarroel and Professor Avi Loeb, very, very acclaimed, highly status, proper scientists who are effectively on our side in the UFO UAP debate. In fact, if anything, I'd say Loeb in particular is a little bit too cautious, but he's still coming around to our position. The Galileo project is essentially a massive sky watching exercise without the beanies and the cans of lager and the £5,000 donations to Dr. Muscle Mass himself, Stephen Greer. Yeah, that's kind of what it is. But thank you all of you for watching Herpanmo TV, much appreciated. Thank you for everyone who leaves comments and indeed has watched the reply to comments video I did the other day and left comments on that. My name is Benjamin Jones. Thank you for watching Herpanmo TV. Hospital Porters, pride and dignity. Stop the New World Order.